This lesson is on classifying linear equations. The objective is to classify linear equations in one variable and determine the solution set of each type. Remember that we use the inverse properties and properties of equality in conjunction with each other to solve equations. We use the inverse operations to isolate the variable. Remember that addition and subtraction are inverse operations, and multiplication and division are inverse operations. The equality property tells us that we have to do the same thing on both sides of the equation. If we add something on one side, we have to add the same thing on the other. Or if we divide by one thing on one side of the equation, we have to divide by the same thing on the other. When we use those properties in conjunction with each other, our goal is to get the equation to be in the form the variable equals a constant. Recall that there's 5 steps to solve linear equations. The first is that we want to clear fractions by multiplying by the least common denominator. Then we want to simplify the expressions on both sides if necessary. In terms of simplifying, we want to distribute if we need to by clearing the parentheses. We also want to combine like terms on each side if we can. Then we want to use the inverse properties and the properties of equality to make sure that we have all the variable terms on one side and all the constant terms on the other side. So if we have all the variable terms on the left, we want to make sure all the constant terms are on the right side. Then in step 4, we want to divide usually or multiply by the reciprocal of both sides of the equation if the coefficient of the variable term is not 1. If the coefficient of the variable term ends up being 1, we get to skip step 4. So for example, if we had 5x, we would want to divide both sides by 5. If it was just 1x or x, we would get to skip step 4. And then in step 5, we're always going to make sure that we check our answer. Okay. Now, realize that some equations are always true, some equations are absolutely false, and some equations are conditional. Most equations are conditional. The equations that we looked at in the previous lesson are conditional. And in order to be conditional, it means that they will be true as long as the correct value is substituted in for the variable. Here's an example of a conditional equation. 3z minus 2 equals negative 11. Now, you may be asking yourself, well, how do I know that that is a conditional equation? If we were to go through and solve this equation, which we do by first adding 2 to both sides, which would then at that point give us 3z equals negative 9. We'd then divide both sides by 3, and we'd be left with z equals negative 3. By using the inverse properties and the properties of equality, we get a solution of negative 3. Negative 3 is the only value that we get as a solution, and it's the only value that can be substituted in for the variable that will maintain equality. It's the only value that's going to work in this equation. A linear equation with a single real number solution is said to be a conditional equation. So when you go through and solve an equation and you get out a solution of a variable equals a number, that's how you're going to know that it's a conditional equation. Sometimes when you solve an equation, you're going to get a solution statement that is absolutely false. this is a contradiction. And if you think about what contradiction means in the English language, that makes sense. Something that's false tends to be a contradiction. In this case, there's no solution. So something like that would look like 5 equals 7 or 0 equals -2. Those are contradictions. Okay. Here's an example of a contradiction. X minus 3 equals x minus 11. Now, at first sight, you're not going to know that that's a contradiction. But if we were to go through and solve this equation, the first thing we would do is get all our variables onto one side by subtracting x from both sides. This would leave us with -3 equals -11. -3 does not actually equal -11. This is a contradiction. If we were to continue to solve this, let's say I didn't quite catch on to the fact that this was a contradiction at this point, and I tried to keep going. I could add 3. Oops, let's go back and fix that. I could add 3 to both sides, and that would leave me with 0 equals -8. That's still a contradiction, though. So, regardless of whether I notice it here or here, the statement's still false, it's still a contradiction, and I'm still going to end up with no solution. A linear equation with an absolutely false solution statement is said to be a contradiction. Contradictions have no solution. In other words, there is no value for the variable that will make this a true statement. So when you go through and solve the equation and you get to the end, and the left side and the right side have two numbers that do not match up, that's how you will know that you have a contradiction. The other situation that you're going to run into is called an identity. Sometimes when you're solving a solution, you're going to run into a statement that is absolutely true. This is the case that's called an identity. And in this case, there's an infinitely many number of solutions. You're going to come up with something like 5 equals 5, or -2 equals -2, or x equals x. Here's an example of an identity. 2 times the quantity x minus 3 equals 2x minus 6. Again, at first look, you're not going to know that this is an identity. You're going to have to go through the process of solving this equation. We would start out by distributing that 2. Once we distribute that 2, we're going to end up with 2x minus 6 equals 2x minus 6. At this point, you might notice that the left side and the right side are exactly the same as each other. When the left and the right sides are identical to each other, you know you have an identity. Now, had I kept going at this point, I might be tempted to try to get all my variables on one side. If that were the case, I would still find that I have an identity. -6 equals -6. The left side is still equal to the right side. I still might be tempted to go even further. I could add 6 to both sides. At that point, I would get 0 equals 0. Regardless of whether you see the fact that you have an identity here, there, or even here, the result is the same. I have an identity, and there are an infinite number of solutions to this equation. What I want you to do now is try a few on your own. See if you can decide if this is a conditional equation, a contradiction, or an identity. Go ahead and pause this video, see what you can come up with on your own, and then hit play and see if your answer matches up with mine. Did you get conditional as an answer? When you go through the steps of solving this equation, you should get a solution of y equals 16/5. Because there is a particular solution to this equation that can be plugged in to make this equation true, it is a conditional equation. Try this one next. Do the same thing. Pause the video, try it on your own, and then see if you agree with mine. Did you get contradiction on this one? When you go through solving this equation, the left side looks kind of similar to the right side at first, but when you go through and end up solving, you end up with 4 equals 8, which is a contradiction. Now try this one. 11 equals s minus 6. This one was the easiest so far. All we had to do was add 6 to both sides, and we end up with a solution of 17 equals s. And because it has a solution that makes the equation true for that particular value, it's a conditional equation. Here's another one to try. 2 times the quantity 2q minus 3 equals 4q minus 6. Pause it and see what you come up with. This one's an identity. Once you distribute on the left side, you end up with 4q minus 6, which is exactly identical to the right side. If you didn't quite pick up on the fact that this was an identity at this point, you could keep going. Try to get all your variables on one side, at which point you would end up with negative 6 equals negative 6. This would still lead you to the same end result of having an identity. Okay. Here's a challenging one for you to try. 6 times the quantity y minus 1 minus 2 plus 2y equals 8y plus 4. How'd you do on this one? This one was tricky. We had to distribute and then combine like terms on that left-hand side before we even thought about using the additive inverse properties and the properties of equality. Once you did so, though, you should find that this is a contradiction. So, remember that to solve linear equations, you're going to use the same process that you did in the previous lesson. You're going to clear fractions first if you need to. You're then going to simplify each side of the equation by distributing and combining like terms. You'll then get all the variables on one side, all the constant terms on the other side, and then you'll divide the coefficient of the variable term. And then the last step is to check your answer. Once you get your answer, remember that there are a couple different situations you may run into. There's a conditional equation, a contradiction, and an identity. A conditional equation is when you come up with a single solution like x equals 5. A contradiction is when you come up with a situation like 10 equals 1. It's not true and there is no solution. And an identity is when you come up with a solution like 2 equals 2. It's always true, and there are infinitely number of solutions.